It's seasonal, it's a single generation, and they're in the autumn, coming from now September, October. Right. And it is, for us, on the northern edge of its range. So how are these things interacting? Forage doesn't seem to be a problem. The nest site is probably not a big problem on a landscape scale. This is interesting because most bees tend to be spring to midsummer. Late summer or autumn bee is an unusual thing. There are a few around the Mediterranean which are tied up with crocuses, high altitude crocuses, which are autumn only. This is another funny one. And it's certainly spreading northward. Right, now this is the UK maximum temperature graphs from the Met Office. And look at this line, the black line here is the mean. This is the September, which I'm taking as thing. And look what's happening in September. We are warming. If I'm warm enough, I've got to actually complete my life cycle before everything shuts down for cold. Yeah, even in the winter, honeybee colonies don't produce a lot of larvae. They all sit quietly waiting to get warmer again. This is now warm enough for Colletes hederae, particularly when it's got nests in warm south-facing ground, for the larva to get to the pupil stage before the winter comes. And I'm pretty certain that generally, and so now what I'm suggesting is that this signature of warmer autumns has been going on for quite a while, 50, 60 years, since this thing moved out of the Mediterranean. So I'd like to look at several other species just to give you some ideas of A, the variety of bees, and B, how they match up against this and what they've been doing. Bombus hypnorums, the other one which you come across a lot. You get asked to move these things. They're actually quite aggressive. If you get most bumblebees, they roll over and wag their leg at you and probably squirt urine at you, but they won't sting you. This one, if you start meddling around near a nest, tends to sting. The reason for this, as far as I can see, is that this is a species which tends to occupy holes in trees. Holes in trees are particularly occupied by birds and squirrels. So there's a fight for the nest site. And so this thing has to defend its nest. In fact, it's been known that a queen Bombus hypnorum will find a tit nest and sting the sitting tit until she actually gives up and goes away. So quite aggressive. And you get all the males around the entrances to the nest boxes and things, yeah? This started a species that originally was boreal, was in the pine woods in the north of Europe and Asia, and has spread all the way down to the Mediterranean and actually come back to us and arrived here in 2000. So let's have a look at how that ran. Oh, this one should have run in one. No, it's all right, it did do. So here's your first introduction. That's the very first place it was seen. We probably missed it down here. And it does this, big jumps. It's quite a good colonizer, isn't it? By 2014, it's done that. And by 2024, modern one, it's right up into Scotland. Sorry, that just killed it. Okay, I've run on to here. It's widely pollinatic, goes for all sorts of flowers. It's a very good pollinator of raspberries and blackberries and things like that. So no shortage of food. That's not changed. That's not something that's changed. Its nesting site is aerial, often a bird's nest. Most bumblebees do not nest in the air. They do not nest above ground. They nest underground or one or two of them on the surface. So it's an unusual nest site. It's colonial, has 2 nest cycles per year, so it gets 2 goes at getting numbers up, which is pretty good going. It's nearly as good as a honeybee having a continual colony. It keeps pushing the numbers up. And originally a boreal species, so warming is not the factor. Now, given that this thing started moving, and we got records for it starting to move in the 1920s, what has been happening which has given this a boost? What do we like putting in our gardens? Where do you, if you get called to a bumblebee nest, find most of these bumblebees? In bird boxes. We've actually made huge number of extra nesting sites. Holes in trees, they are used by birds in the southern part of the range, but they really are a boreal thing. Most bird nests have to be in trees because the ground's too cold. Up here, you can have open nests in the open and the tree, you can have nests on the ground. It's not too bad, but in the Arctic and near Arctic, it's cold. So your birds tend to be hole nesters. And that's why the bumblebee developed. So that, I think, is us humans changing that. Right. So let's have a look at another bumblebee, Bombus sylvarum. If any of you follow any of the bumblebee work, you'll recognize this as being one that's being claimed as greatly declined. And they ain't wrong either. There on the left is the distribution before 2000. Most of these records are actually before 1970. I've been back, I've checked lots of these, I've checked lots of sites. Bumblebee Working Group, the BAP Biodiversity Action Plan thing, we actually identified one population there which is probably linked to this one out there which seems to be on its own, and one on Salisbury Plain, which is here. That was it. And if you look at the next map, it's still it. Why should this, which in 1950s, 4950, was described as being everywhere, nesting in all sorts of silly places, old coats hung up in a shed and things like that, have disappeared? Well, if you think back to that graph that I showed you, what happened in the 1960s was the loss of clover in farms. Every farm prior to that which had a horse would have fields of clover hay in order to feed the horse and make it work in the winter. All gone with tractor. And my guess to this one is that that loss of forage, very widespread forage, is a major decliner here. Why it's hung on in these places, not sure. These are all lowland ones, wetlands. That's Somerset Marshes. That's Gwent Levels. That's round the back of Swansea, Cardiff there, low-lying ground. And some of the work we did on this bee quite likes being in wet grassland. It's a late maturing bee. The queen doesn't come out till May, and wet grassland tends to have a late flowering and have a lot of other suitable flowers, Lamiates particularly. Same here, this is wet grassland. And I think the fact that most of this, apart from Salisbury Plain, is an oddity, and even it's not doing well there. Most of the rest of this has all gone into intensive for agriculture, and the late flowering grassland, unimproved grassland, is just gone. And bumblebee can't cope, so it's just left there. So that one really has declined enormously. But interestingly, there's not a lot of difference between 2000 and 2024. It has done its declining. Right, so next one, I'm gonna stop doing that because it just makes the whole screen go. Right, so foraging is polylactic, but a strong preference for clovers. Does go for other things. It's a surface nester, and this is another thing I think contributed to all this little group of bumblebees disappearing. It's a carder bumblebee. It makes a nest. The queen gathers together some dead grass stems on the surface and weaves them round into a little ball in which she makes her first nest. Keeping that nest warm is a problem. And so the structure, the grass structure above it, needs to have some litter, but not be dense, not like our road verges anymore. And that is related again to rotational grazing systems and mixed farming. You tended to get much more open grassland with a bottom in it, particularly as that was left for 4 or 5 years before it's ploughed again. And that was the second factor, the loss of clovers and the loss of this grassland structure. And there are 2 or 3 other bumblebees in the same boat. The only one of the carder bumblebees which actually has become common or stayed common or gone really common is Bombus pascorum, one I said earlier on, and that does nests in lots of other places too, and it forages much more widely. So it's a colonial species, one cycle per year, but other bumblebees do perfectly well like that. So certainly on the northern edge of its range, and Paul Williams at the Natural History Museum did a big PhD on it, and he said this is one of the big factors that affected it, that if you're towards the edge of the range, you might be rather more picky about what you do. I suspect that's because there isn't enough time to do what you want to do rather than anything else. And we had lots of arguments about it. The edge of range, I think, reflects in the fact the grassland has to be just the right structure. The forage amount has to be the right structure. But he's generally right. And the edge of the range, things are more picky than they are in the middle. So that one has really gone down, but it went down before 1970. Bombus terrestris, on the other hand, is an amazing beast. By the way, you can see how bumblebees and honeybees are related. Here's the pollen basket open. There's one central peg in there, and they collect wet pollen, all the bumblebees. They're very closely related, all of them. Bombus terrestris is an amazing thing. It can have up to 3 generations in a year. Really getting supercharged here. It goes to anything. It's been known as flying in the winter here since 1990s, first noticed. I was one of the first people to realize it was doing this when my small children then, about 3 and 4, I used to take them up to the swings and suddenly realized that these bumblebees were foraging in January. And then lots of other people did lots of work on this. It's what it does around the Mediterranean, because around the Mediterranean, the flowers are actually during the autumn, winter, spring. You don't fly for a bumblebee in the summer in the Mediterranean. And this thing has great plasticity. It goes for all sorts of things. It's the main culprit in biting holes in the bottom corollas, which honeybees love because then it gets to the nectar. Yes, if your runner beans don't have crop on them, this is the culprit, not the honeybees, nothing else. This is the culprit because the pollination mechanism of runner bean has like a hook with the anther and the pollen in it, and it's got to be turgid, full of liquid, liquids, full of water, sap. And if the bottom is bitten through to get to the nectar by this thing, go floppy. And the whole system is a little spring and dobs a tiny bit of pollen just here where the bee can't clean it. And of course, gone turgid, doesn't happen. Your buff bumblebees, your tawny type bumblebees, Pascorum, they go in the front end, they don't bite. And they're the ones you want, two species which go in the front end, they're long tongued. This is the reason why runner beans don't set, unless of course they're modern hybrids where they've been made to. But runner beans traditionally has to outcross. That was a fascinating bit of work I did for one of the big market gardeners. Right, so here's the spread of it. Must remember, up here is not many people, and certainly before 2000 there were very few people recording bumblebees up here. So there are some dots, but even then we are pretty certain it really wasn't out here. By 2004 we're getting more dots, but they're getting suspiciously close together. That could be one person. Down here doesn't look like one person. And when you get now, it's gone right up on these islands. Yeah, right out here. This thing is spreading 3 generations a year. It likes being warm. It's a thing that goes from the Mediterranean. In fact, it goes just into North Africa, go right through Europe. You're well in the middle of the thing. So here we are, forage, widely polylectic. It can go for anything. No problem there. Underground old mouse and vole nests. There are plenty of mice and voles around. One of my cats managed to catch 2 or 3 voles a day and eat them. It's a colonial species, which is good. And it's a big colony too. The nest size of these things is 600-700 workers, unlike things like Silvarum, which are 20 or 30 workers. So huge queen production every year. And it's well in the middle of its range. Okay, next one then. Right, going to the other end of the size range. This is one of the mining bees. It's one of the Collectes, and it's one of the ones that has a queen and one generation of workers here, but 2 generations of workers further south. Quite a lot of work being done on this, a thing called Lasiglossum malacurum. It's all of 8-9 millimeters long. It makes little holes in the ground, which it always makes it in ground that's slightly wet. And if you find nests of this, you'll see there's a collar of dried mud around the nest entrance. Queens come out, they're mated in the autumn. They don't hibernate where the new nest is made. We're certain of that. We don't know where they hibernate, but they don't. It's very unusual. Come out in the autumn, in the spring, and they start these nests off in March, April. The queen forages like a solitary for 2 or 3 weeks, probably 4 weeks maximum. She has one brood of workers. She closes the nest and sits on them until they hatch. Then the workers go off and you see the nest open again. The queen doesn't come out. Eventually she dies. New females and males come out in the autumn, mate, and the female overwinters and the cycle starts again. This one, well, remember all the fuss about neonicotinoids. I'm not saying they don't kill things, they're meant to, but some of this story makes you think, I'm not sure. Here's the distribution in beginning 2000s. Very restricted to warmest. There's the warm part, the Thames corridor, south coast of Britain, few dots out here, not much. 10 years later, and then up to here. This dot up here is interesting. I think I need to chase that again. I've done it once, but I've got a feeling that's a bum record. And then by 2020, modern time, it really has spread quite well up here. Quite a hard cutoff though. It has to have a certain length of time in order to complete the cycle. Still too cold, too short season up here. So, widely pollinatic. The mining bee, bare and sparsely vegetated ground, because that's warmer. That makes you complete your cycle quickly. It's a colonial species. It is good because you can actually put a bit of strength, a bit of manpower into gathering your food. And it's still on the northern edge of its range. But look what's happening. Here's the mean anomaly again. This is the annual one. Here we are, 1975. There's the previous average. Look at that lot warming up there. And that warming and extending of the temperature envelope over the months, if we look at it properly, is what is driving the success of this species. It's got time to complete its cycle. The other thing about it is shown in this picture. Oh, sorry, this is another modeling graph. This is a model I worked on with CEH. It's got some good points and bad points. I'll come back to it, but you can see the period 1990s to about 2006 was a very warm period. You can think back that far. Hot summers, long hot summers. After that, the weather collapsed. That's what happened to the numbers. Now, this is best guessing. Modeling is best guessing. It is not reality. You must remember that. But there's a good amount of data for this. And the grey area is the uncertainty. It looks pretty good. And it does seem to match what people have noticed. This is the thing I wanted to look at. That there is a nest. That's 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 a nest. And where is it? It's in the tram line of a field of cereal on Syngenta's experimental farm. And if that isn't being plastered with insecticide, nothing is. It's only part of a story. It was a very nice one for people in towns to grab, but it really didn't make complete. I'm not defending them. I worked for Syngenta, and we had lots of argument about this. There is overuse of pesticide, undoubtedly, and people throw excess pesticide on. I was working with a golf course a little while ago, and they had some bracken. I said, well, you could use a total herbicide on this. I got found out 2 days later saying, well, I've sprayed it once, nothing happened. I sprayed it again. I'm going to spray it with double strength. So it is perfectly possible to be stupid with these things. They're dangerous chemicals. But that certainly was not dying from pesticides. So we'll see. This thing seems to go to anything in the arable landscape, and it's now one of the commonest bees in the southern half of Britain. So there's another little bit. Conversely, this little thing, and it's not a nice photo, it's one I took in 1985, 86. It's an old film photo. This little thing had a little period when it became rather commoner, never common, but on several of the woodlands on top of the downs near me, I could find it. It then disappeared. Last 20 years, I haven't found it at all. It nests in deadwood. It's one of the cavity nesters. It has a brush under here. You can't see it on here, but I'll show you another one in a minute. It nests in deadwood. It likes it slightly rotted because it actually burrows, makes its own nest. It doesn't use a pre-existing cavity. It bites one out. And one of the reasons I think this thing has collapsed and the areas were before is that modern forestry clears the land after felling with a big, ferocious flail. And that smashes up all the deadwood that used to be left. When you took a crop out, I've seen this thing in old larch stumps, in large numbers. When you took a crop out, a forestry crop out, you used to leave the stumps, particularly if it was conifer, and you'd replant. Now they clear completely, so it's absolutely flat. It makes life much easier for them, but it destroys the nesting habitat for this. Part of the problem. Recently, a friend of mine has managed to find a nest in Kent, and it's a couple of records from Kent, from the Weald. Nothing up this end. I keep looking, but here it is. So here's the picture. There's all of the records known before 2000. So it's quite widespread, very southern. Just a few here on the north end of Kent and a few around me here. One or two out here is interesting. And then nothing really new on the next one. The two pictures are virtually the same. Big mystery. I say my one guess is that forestry practices might have changed it. But equally, I've been to places where they haven't changed and I still can't find it. And that was the position between 1940s and 1970s. It was unknown again. It's unknown in Germany, or hardly known in Germany. And again, Germany tends to have forests which are either forests or cropland. There's very little graded area between. They had no coppice type cycles, which we used to have, which would keep an area of growing forest with rotting wood at the bottom. So something about that, but it's a big question, but it certainly is a decline. Most definitely is decline. So it's listed here. It's polydectic, excavates softwood in sunny locations, single generation, which is never good news, particularly, and it's within its main range. Anyone with bright ideas, please let us know, and then back it up with some research. That's the model graph for it. It's got so few records. I mean, this is just a guess. It's crazy. I'll come back to this point here in the modeling graph. Down here, we're starting to get to where we have a decent amount of data. Up here, we have nothing. This is fairy tale. Megachile Biela. This is one of the cavity nesters. There's the pollen brush. You can see it underneath. It's a leaf cutter bee, and here she is happily sealing up a nest she's made in a bamboo that's been made for her. If you have these bamboo nests in your garden, just take a cane of bamboo and cut it into sections. You don't need to buy a fantastic bee nest or anything else. Stick it in a bit of pipe and put it on against the sunny wall. This thing will turn up. Fascinating to watch. Male has great big front feet, and it uses those to clamp over the eyes of the female when it wants to mate, so the female doesn't go anywhere. Here's the distribution. Does look to be going a bit south, a bit north again, though. Now there's the line. There are a few dots out here. By the way, this was traditionally the warmer side of Britain. Wetter, but warmer. Gardeners will recognise one or two big gardens up here, which actually can grow some amazing plants. This is the colder side. Look what's happening here. It's going up the colder side. And then you go to the next one over here, and it's continued to spread. In gardens, generally around, you know, where there's lots of gardens and people recording, it's absolutely brilliant coverage. So it's polydectic, excavates softwood or uses cavities. Single generation, I think, might actually be getting a second generation in, and it's well within main range. So nothing likely to be going on with it at the moment. There's the graph. Again, a lot of uncertainty. Basically, the uncertainty, this graph is working on idea that if I can't find it in the same place 2 years or 3 years running, it might have gone. Well, when you look at the amount of data we're dealing with, you'll see that that's a pretty big guess. But it does seem to increase in that warmer period and possibly going down, but a lot of uncertainty in the graph. This is a mining bee. It's a 2-generation mining bee, think Andrea flavipes. It's one which is often recorded as a funny honeybee. You can see why it's a funny honeybee. Look at the back leg, flavipes, red legs. The hairs are bright orange, but these bands, okay, they won't fool you lot, but they fool other people, look a bit like honeybee bands. And it's the right size and does very much the same thing. 2 generations a year. But look, it's very hard cut off. There are a few dots up here, which, okay, most of the population is there. 10 years later, it's there. And I can't show you that one terribly easy because I can't see it. It's underneath my screen here. But that's become even more northerly. Well, what's about it? It's widely polylectic, so no problem with going for anything. No strong preferences. It's a mining bee, likes bare, sparsely vegetated ground, just like the Colletes, hederae. 2 generations, so it gets two kicks at the boot. The first generation has poor weather, the second one might have good, and vice versa. So it has plenty of chance to try and get past weather problems. It's on the northern edge of its range, but it's definitely spreading. In fact, this is the most commonly recorded mining bee in the BWARS dataset, even though it doesn't go right far north. And there's the graph for it, very similar to the Megachile graph. So I'd ignore this end completely, but there we are. There's the warmer weather, cooling down. And 2018-19 on, the weather starts warming up again. This is its cuckoo. This one actually lays its egg in the cells of Andrea flavipes. The larva hatches first, kills any or destroys any egg of Andrea flavipes, and then eats the food that's been put away. It has fluctuated like flavipes. 1930s, another warm period. This became commoner, and it's become commoner since about 1980, late 80s in Britain. So there's the overall distribution, like its host, moving northwards. Again, I'm a bit concerned about that one. Funny one up there. And then real recently consolidating out here. So it's widely polylectic. Well, no, it's not widely polylectic. I've got that wrong. It goes to lots of different flowers, but it doesn't collect pollen. So it's not really polylectic, because polylectic is to do with pollen collection. So bad boy. It's a cuckoo bee. The host in bare and sparsely vegetated ground, 2 generations, and it's on the northern edge of its range. But it follows its host. If its host's doing well, it's doing well. 40, 50 of these cuckoos, and a total population of 260. So they're not an insignificant component. And there's the graph. Again, very similar. Warmer period here, dropping off a bit there. Andrea bicolor. Andrea bicolor is another small mining bee. It's about half the size of flavipes. Its distribution is right from Scotland down to us. It has 2 generations in a year, and it's again a very, very frequently recorded bee. There's the general distribution. I think a lot of this is just where it started to be recognized rather than colonization. It's not that different from the 2 years. Whereas it's colonization, I expect that to fill in a lot more. So it's widely polylectic, mining bee, 2 generations, all good news, middle of the range. Now, this is the problem we have. This graph appears to be showing it to be declining enormously. If I show that graph to anyone who works on this bee, they just fall about laughing. This is where you need to be really, really careful of modeling. This thing is so common, it rarely gets recorded more than once if you've seen it. Oh, I've seen it there. Again, I'll never record it again, because we record rarities, not common things. This point up here is just pure fabrication. I'll show you that in the end. But down here, but it does look at that. That little bit of the graph, I think this model where it's running on sensible data is actually quite good. But you have to be careful where sensible data is. At the moment, this decline is one of the declines used to justify the death rate indicator, which I'll come back to. Rubbish. Bullshit. Absolutely. Right. Just to say how you be careful of stories being whipped up because they make a lot of fuss. This is Bombus pascorum, which I started talking about a long while ago. It's one of the carder bumblebees. It's the only one of the mainly surface nesting ones, which is still common and widespread. All the rest are declined, hugely, like Silvarum. Not necessarily as much as that, but declined. This one does a number of things differently. It's a thing you often find in your compost bin. You won't find Silvarum or Humanus or any of the others in a compost bin. This one can nest in much more varied situations, and it's done very well in gardens. It's actually the most recorded bumblebee in our data. Really odd, just a few changes in behavior seem to make this one really, really work. However, in the 2000s, there was a paper, Bombus pascorum 50% decline by 2011. Made a lot of fuss about it. People made quite a good career out of some claims like this in the 2000s and the modelling. Oh, look at the data. Yes, Rob is just laughing. You just got to laugh, haven't you? You can't do anything else. And I am very, very wary. I actually get cross with one or two very public people who keep prattling on about declines without actually understanding what the heck's going on, except the fact it makes a lot of fuss. We need to have science about this, not PR. And look at the graph on that. Again, it's our best recorded bumblebee. Not, you know, this isn't too bad up here on the error. There it goes. Again, look at that. It's interesting. Even there, that didn't like that 2006 to 2010 period. That is reflected in virtually everything where there's good data. Back to what I said, seasonality. If you've got extended poor seasons, and you know that from your honeybees, yeah, you look at honey productions, I'll bet it does exactly the same. I haven't looked at it. There are Robert, there's a challenge for you. Okay. JNCC indicator. This is a thing that's being thrown around, status of pollinating insects. And it's using that model, but it's using that model right from 1980. It's saying the 100% occupation was in 1980. I'll show you the last slide in a minute. You'll see what nonsense that is. Here's this bit. Yep, here. That line there should run through here somewhere. How can you take 1980 as 100%? Especially when you see this. There's our data. There's 1980 for our data.
Mike, your cursor seems to have disappeared.
It seems to have died, doesn't it? Yes, sorry, thank you. Annotate. Let's try spotlight again. Right. Yes, you'll need that there. Have I got it back? No.
No, I can't see it.
Ah, that's better.
That's
right.
It.
That's our data. That's all we got from 1800 on. So those first extinctions were right down on very low data at all. Yeah. 1980 here, we started collecting data. Over here somewhere, I said I can't see it because I'll move that bit so I can see it. Right, that is where we started computerizing the data. Just look what happens there. This is about 2000. This is reasonably good. That's just because we weren't collecting data in 2016 when this graph was done. We were in 2016. That bit is reasonable. Anything based back here is fairyland. Just hasn't got the data quality. So that 1980 point, you've got to look in this lot here where there's lots of data, and the data must have a reasonable overlap. People must record the same things again and again, or we might need to know that they're trying to record them, which is the thing with Andrena bicolor. Because it's so common, no one bothers re-recording it. Okay, hopefully that's given you something to think about. It's given me a bit of fun doing it. Thank you very much. Over to you, Robert. I'll stop the screen share.
Brilliant.
Pause the share. Stop the share.
Thank you. Thank you so much, Mike. Yeah, that was really, really good. I don't really know where to start. We've had a few questions come in. Let me just see what we've got up here. Clive Hill, who is actually writing a book for us on Bombus hypnorum. He said it's the preferential nesting sites, not just bird boxes, but loft insulation is also
correct. Yeah,
very, very common. Yeah.
Yeah, absolutely. Because you think about it, loft insulation is a massive bird box. Yeah. Prior to what, 1970s? Not much loft insulation anywhere.
No. Yeah. So
basically, it's an aerial nester that wants somewhere warm. You see, the queen has to start that whole thing off on her own, and she sits on top of a lump of pollen and nectar and vibrates her wings to warm it up. So anything that makes that warmer is good news. It's why most bumblebees use vole nests, underground vole nests.
Right. Here we go. One from Archie McClellan. You said there's little evidence outside the UK for insect decline. What do you think of the peer-reviewed study by Sancho Bayo, which raised considerable alarm a couple of years ago, suggesting that insects could be wiped out in a century? He admitted in an interview that much of this was his gut feeling, but thought it was worth raising the issue.
Well, yeah, I think you said it, haven't you? Lots of those early papers were pretty dodgy, great leaps of faith and everything else. We do have a continuous amount of data, and we are able to say some things about some of these things. One of the big things, that big German study that came out, they dealt, you only need 3 big beetles or grasshoppers to get in to really knock your biomass up. Placing a malaise traps, which are basically tents, is very, very, very site sensitive. And this data was just pulled from anywhere with no replication, nothing. Yeah, as I said at the beginning, I have no doubt that because of our, as a species, demands on the countryside, the opportunities for other organisms are decreased. I've no doubt about that. But unless we are all going to suddenly go and jump off the cliff and solve this problem that way, we ought to be scientific about it. We need to think about it, and we need to make rational decisions.
An interesting question from Jonathan. I think what he's asking is whether sometimes bees hibernate for more than 1 year. He says, is it correct that combat high seasonality, the bees sometimes emerge in year 0, sometimes year 1, and sometimes year 2?
Yeah, I'm certain it is. It's not well known in most of the temperate species. There are a number of Arctic alpine and desert species where it's definitely well known. There's a thing called Osmia liana. Osmia liana. Sorry, start again. Osmia inermis, which is an Arctic alpine species, just exists in Scotland. We did. We haven't been able to find it for the last 20 years. And I've had a nest here under a stone, which has emerged over 3 years. Whether they actually turn into adults and wait, or whether what's known as a pre-pupa, which you do have in honeybee as well, actually wait, is the waiting stage. That's the normal waiting stage. I don't know. I don't think anyone knows ins and outs, but it does look, if you collect nests, stem nests, there's a whole group of species that nest in bramble stems, for instance, you occasionally find that there's still one left in there. The other thing that happens with that is, of course, if you're at the front of the thing and you decide to wait, Fred behind decides what to get out, that's tough for you. But yes, and it's well known in desert species as well.
Yeah. A question from me. Your maps, I don't know whether Ireland is excluded, but Ireland doesn't seem to get the thing.
Well, what's the problem in Ireland at the moment? For a very long while, there was a big standoff between the Éire Irish and the British, the rest of the islands, GB and Ireland. It was resolved with the idea of Great Britain and Ireland, which is fine, but there was no data to be shown for Ireland for a long time. We actually work with the Irish group, Una Fitzgerald, and we do give them data and they give us data, and we can produce Irish maps. The worst thing about trying to produce Irish maps with data, even access to data, is that the grid lines for Ireland do not line up with the grid lines for the rest of the Great Britain. And the reason why there's no data in Ireland there is because when my son, who developed this mapping, was doing it, he just said, this is one problem too many at the moment to translate grid lines. But if you go to the Irish, I can't think what they're called now, Una Fitzgerald site, you will see all our data plus theirs on their maps. So we are sharing the data, but displaying it is a little bit of a problem. I mean, this is all this mapping and everything else is being done voluntarily.
And they've got a good population of bees there, have they?
They have quite a lot. Don't have as much as us.
Yes.
And again, they've got some new ones turn up. A thing called Bombus monticola turned up in the 70s, and that's been shown to have arrived from Scotland, from the west coast of Scotland. It's amazing. And there are a couple of other bees turning up. One, Osmia piccola, bicornis, which you probably know as Osmia rufa, the one that gets sold or gets encouraged in bee nests for gardens. That's turned up in Ireland. We strongly suspect that that was because people selling populated bee nests. But yeah, there are new things turning up in Ireland, some of which seem to be perfectly natural spreads.
Okay.
There are two that aren't natural. There's a wasp turned up that's in the Mediterranean. I'm waiting to see if that's turning up the next year or not.
Oh. I've got another question from Clive Hill about hederae. What can you tell us about the nest burrows? How long are they? How deep are they? Are they lined? Is there a single chamber at the end?
They are not very deep at all. They mustn't be deep or they won't get the warmth. They're very similar to Colletes succinctus burrows. They branch off just below the surface, 2-3 centimeters below the surface, and you get like a whole fingers of nests of individual cells coming out of them.
Ah, right. Okay.
But if you want to go, the way to do it is to get some very weak plaster of Paris in a squirty bottle and squirt it into the nest, and that lines the edges, and you can actually excavate it. I've done it for a long time. It's great fun.
One from Jeremy. Would the plant specialization of the species be a hangover from the original wasps?
No.
I.e. a solitary wasp species predated an insect that specialized on one plant. Over time, that wasp evolved into a bee species, and that bee species then specialized on the flower of the host plant.
Quite probable. Unfortunately, we don't have the information to be sure, but yeah, it's got to be something like that. It's got to be the swap from the wasps. But as I said, and your correspondent there has picked it up, the bees are only wasps, which are collecting pollen rather than insects. Pollen's easy to move. You can pack small packets and lots of it. Other insects are relatively big.
Yes, so you don't need many.
Yeah.
Good. Well, that runs out of the questions which I've got in front of me. It was good to see the shrill carder bee, Silvarum, because that's
Well, up by you, yes. Cliff Pools is a good place for that.
Yes, that is. Yes, certainly is. It sounds just like a honeybee. So,
doesn't it just? Yes.
It fools me. So thank you, Mike. Thank you really very, very much. That was fascinating stuff. And I'm sure we'll all be looking out for all these little flying insects now. I mean, where would be a good place to start if anyone is interested in taking this up?
Start in what way? Start looking or start finding a bit of background information?
Start looking and recording.
In your garden.
Right.
You'll be amazed how much. I mean, I'm in Midhurst, I'm on a sandy soil, but I've got over 200 species. I would think that's bees and wasps together. Most gardens are going to get 50 or 60, but some of these things are tiny.
Yeah.
Good place to go and look for some ideas of what you might be seeing is the Bees, Wasps and Ants website.
Yeah. Right.
Bees, Wasps and Ants Society website, and lots and lots of data in there. Some of it's getting quite old. We need to update it, but again, it's what can you do with a voluntary society? There's limits, as you all know.
Yeah.
But that's quite a good starting point. And
Yeah.
most of the stuff on there is carefully, checked, and we're reasonably happy with it.
Are there local groups with?
There's no local groups. Again, COVID is upsetting everything. We haven't held an AGM and a workshop for 2 years. Best thing, I mean, if you join, BWARS is not terribly expensive to join, it's a bit more than you, but there is a newsletter, and most people are very happy to share. I mean, anyone's in Midhurst area wants to come and have a look, West Sussex, Hampshire. There's room up here, there's a collection here, and I'll talk forever about things. And I think you'll find others, like Oxford Museum's always very good to go into, always very helpful. It's a matter of finding someone near you and then sort of just jogging along. But the real thing is just have a pair of eyes open and stand still and watch. And particularly watch flowers, yellow composites, particularly dandelions, ragwort, hawkweeds, things like that. Lots of species going on there. Okay.
Lovely. Well, thanks again. And I think perhaps if I can just ask people to clap. Thank you very much. Thank you.
Lovely. Well, thank you for asking. It's great fun.
No, thank you so much.
Okay.
I need to make an apology. I forgot to switch on the recording, and I
saw it come up. That's good, because I can give it again now.
Yeah, and I forgot to send it to YouTube as well. So I apologise for that. You're about
4 out of 10.
Yeah. Thank you. So
that's very good, because I can give the same talk and that'll be okay.
I'll try and record it next time then. So once again, thank you very much, Mike. And I'm going to leave you now with the slideshow again. And thank you everyone for joining us tonight. And I look forward to seeing you again with Marla Spivak in November. Thank you very much. Good night.
Yes.
Very good.
Thank you. Where am I? Share screen. Just to end with these. Good. I'll just leave those. That's Holm Pierpoint Hall in Nottingham. Martin there with his bee cello. And members, of course, get the booklets, and some of you will have had maybe the latest one on the bee microbiome, which was a really good read, I thought. Anyway, thank you all again for coming tonight,